Okay, we are solving log and exponential equations here. This is the test review. The first set of problems wants us to convert from exponential form to logarithmic form. I'm going to remind you that we know that b raised to the x power is equal to y can be written in log form, where log base b of y is equal to x. So the base becomes the base of the log, x becomes the solution, and y becomes the input for the log. Now, these problems right here do not have an equal sign, and we talked about this in class, but you can evaluate each of these exponential expressions to tell me what they are equal to. 7 squared is equal to 49, and 5 to the third is equal to 125. 2 to the fourth is equal to 16. 11 to the 0 is equal to 1, and 3 to the negative 1 is equal to 1/3. Now, that's not what you were asked to do. You were asked to convert from exponential to logarithmic form, and so we want to go from this to this. We want each of these to have a log in the end. So this first one right here, the base is 7, so this is log base 7 of 49 is equal to 2. This one right here has a base of 5, so it's log base 5 of 125 is equal to 3. This problem has a base of 2, so it's log base 2 of 16 is equal to 4. We have a base of 11 here, so this is log base 11 of 1 is equal to 0. And then this one right here, log base 3 of 1/3 is equal to negative 1. All right, the next set of problems wants us to rewrite equations in exponential form. We're converting from logs to exponents, and so again, I'm just going to remind you of this property right here, which says that if you have a log expression, you can rewrite it as an exponential expression. This base number becomes the base, the number on the other side of the equal sign becomes our exponent, and the number inside the log is our solution. So if I want to rewrite this as an exponent, this is 8, because we have a base of 8, it's 8 to the first power is equal to 8. And the great thing about these is when you rewrite them as exponents, you should come up with a true statement. So is 8 raised to the first power 8? It is. So we know we've done this correctly. Number 7, we're looking here for our base. This is a base of 3 to the third power is equal to 27. Here I have a base of 9. So it's 9 to the 0 power is equal to 1. Again, we've come up with true statements for both of these exponential expressions, right? 9 to the 0 power is 1. 3 cubed is 27. This one, 7 squared is equal to 49. And then this one right here, 4 to the negative 1 power is equal to 1/4. And again, all of these are true expressions. And so we'll just take a minute right now to remind ourselves that negative exponents take whole numbers and make them into fractions. Negative exponents can also convert fractions to whole numbers. But if you start with a whole number and end up with a fraction, or start with a fraction and end up with a whole number, it's because of a negative exponent. All right, evaluating logs. Remember that we had a question that we asked for each of these problems. And that question was little number to the what power gives us big number. So for this one, we're asking 6 raised to what power gives us 36? All right, that's the question we're asking in words. You know, in math terms, 6 to the what power equals 36. And the answer is 2, right? 6 squared is 36. So 2 is our answer. Please remember that your solution to this expression, your evaluation of this is 2, right? All of this stuff is just work. The answer here is 2. Okay. This one right here, we're asking 5 raised to what power gives us 125? 5 raised to what power gives us 125, right? 5 to what power is 125? And the answer to that is 3. This is 5 cubed is 125. So your solution for this is 3. All right. For this one, 7 raised to what power is 1? And this seems kind of tricky, but if you look back on the other problems we've already done like this, we have 9 to the 0 is 1, and then up here for problem 4, you have 11 to the 0 is 1. And so those are good reminders that 7 to the 0 power is going to give you 1. So the answer here is 0. This one's a little tricky. 9 raised to what power is 3? And you'll notice that we're starting with a big number and getting smaller. I didn't start with a whole number and go to a fraction. I started with a big number and I got smaller. And so if you ask yourself, how are 9 and 3 related? 9 is the one that has to have the exponent, but how are those related? Well, 3 is the square root of 9, right? The square root of 9 is equal to 3. And we can write square root as an exponent. This is 9 to the 1/2 power is equal to 3. So the answer here is 1/2. And again, we know it's a fraction, and we know that because it's going from a big number to a small number, which means you're going to have to take a root. All right, log base 5 of 1/5. You know, again, this looks tricky. It's a whole number and a fraction, but remember, if you look back just a little bit, you'll see that 4 to the -1 was 1/4. So what exponent of 5 is going to give me 1/5? The answer is -1. All right, guys, we are solving exponential equations for 16, 17, and 18. And remember that you solve exponential equations by taking the log of both sides. Sometimes you need to get the thing with the exponent alone first. Sometimes it's already alone. If I look at this expression right here, I have a 6 with an x and a 6 with a 3x minus 2. There are 2 exponential expressions in this equation, and the bases are 6. Okay. So the way that I do this is I take the log with a base of 6 for both sides. So log base 6 of 6 to the x is equal to log base 6 of 6 to the 3x minus 2. Log base 6's, those cancel out, right? We simplify to x equals 3x minus 2, and then solve for x. We get -2x is equal to -2. Divide by -2, x is equal to 1. All right, over here, notice that our bases are different. Okay. We can address the base issue here, or while we're taking a log, we'll go ahead and address it here for now. Remember that you take the bigger number and write it as the smaller number. So I want to know, can I write 16 as 2 raised to a power? Can I write 16 as 2 raised to a power? And the answer is yes. 16 is equal to 2 to the 4th power. And so instead of the 16 right here, I'm going to put 2 to the 4th power. So I've got the 2 to the x minus 21 is equal to 2 to the 4th power. And that 2x that was right there, we're going to multiply by the 2x that was already in the exponent right there. So 2 to the 4th times 2x. So I've got 2 to the x minus 21 is equal to 2 to the 8x power. And again, I'm going to take the log of both sides and I'm going to use the base that is in my equation. So here my base is 2. So this is log base 2 of 2 to the x minus 21 is equal to log base 2 of 2 to the 8x. And those logs with the 2's they cancel out this log expression, and this simplifies to just x minus 21 is equal to 8x. And solve for x. Subtract x. Negative 21 is equal to 7x. Divide by 7. And we get x is equal to negative 3. And that's our solution right there. This one was a little tricky. We had to change the base from 16 to 2, okay? But remember, the way you do that is you take the big number and you write it as the small number raised to a power. So 16 was the big number, and I took it and I wrote it as 2 raised to the 4th power. And then what happens is you multiply those exponents there when you do that. All right, one more exponential equation, guys. Here I've got 3 to the x minus 5 equals 20. Y'all, I need to go ahead and get the 3 to the x alone. And so I do that by adding 5 to both sides. So 3 to the x is equal to 25. And then my base here is 3. So I take log base 3 of both sides. So log base 3 of 3 to the x is equal to log base 3 of 25. This simplifies to just x. I do not know what log base 3 of 25 is. 3 raised to the what power gives me 25? I don't know. It's not a known power of 3. And so just leave it. Just leave it. That's your answer right there. It's good enough. All right, guys. That's it for the front. I'll post a second video with the exercises on the back.